Greenland's hidden lake bursts through ice in surprising event. Greenland's hidden lake unleashes a dramatic burst of water that slices through massive ice blocks, and this astonishing event is stirring up questions about the dynamics of our planet's icy regions. But here's where it gets controversial. While water usually flows downward under ice sheets, a recent discovery reveals a case where it surged upwards with surprising force, carving a path nearly double the size of New York's Central Park. This unexpected phenomenon challenges existing notions of subglacial water movement, prompting scientists to reconsider how we understand ice sheet behavior. In 2014, near the remote Harder Glacier in northern Greenland, an extraordinary flood occurred beneath the ice. It was only a decade later that Professor Mal Macmillan from Lancaster University and his team identified the event while analyzing satellite images for hidden subglacial lakes. These lakes, often formed by meltwater accumulating between the ice and underlying bedrock, play a key role in shaping the ice sheet's movement and overall water cycle. Usually, they drain gradually or sometimes suddenly, releasing water that can lubricate glaciers and accelerate their flow toward the sea. However, this particular flood was far from typical. It involved a collapse of a 2 square kilometer ice area into an 85-meter deep sinkhole, a clear indicator that a subglacial lake had emptied rapidly. Digging further, researchers uncovered a fracture zone downstream that was wholly unexpected. Out beyond this zone, a vast expanse of 6 square kilometers appeared eerily smooth and untouched by the chaos, until the flood's force revealed itself. The scientists saw that instead of flowing downward, the floodwater encountered an obstacle, causing it to push upward dramatically. This upheaval didn't just cause minor cracking. It sent an estimated 90 million cubic meters of water surging through the ice in about 10 days, comparable to the flow of Niagara Falls over 9 hours. This colossal gush tore through the ice, lifting, cracking, and creating new crevasses, reflecting the intense forces at play. Following the surge, the water retreated back beneath the ice, potentially ending up under Harder Glacier itself. Interestingly, during this period, the glacier experienced a significant calving event, where a large ice chunk broke off into the ocean and exhibited unusual increases in flow rate. These changes strongly suggest the flood had immediate and noticeable impacts on glacier dynamics. Robin Bell, a polar geophysics expert at Columbia University, points out that such findings add vital pieces to our understanding of glacial processes and the massive ice loss our planet is experiencing. The critical question remains, how often does such upward water forcing happen, and what role does it play amid Greenland's climate acceleration? Macmillan emphasizes the importance of investigating whether similar events have occurred in the past, as understanding these occurrences could be key to predicting future changes. This story is a stark reminder of how much we still have to learn about our polar regions, and why continuous observation, coupled with advanced imaging, is vital for unraveling the complex dances of ice, water, and climate. Are these flood events rare anomalies, or are they signs of a larger, more rapid shift in Greenland's ice behavior that could impact sea levels worldwide? Share your thoughts below. This debate is just beginning. 90 billion liters of water exploded through Greenland's ice sheet. The Greenland ice sheet has been losing mass at an alarming rate, contributing significantly to global sea level rise. Over the past 3 decades, it has lost an average of approximately 169 billion tons of ice annually, resulting in a total contribution of around 14 millimeters to global sea level rise. Approximately half of this mass loss is attributed to surface mass balance processes, primarily driven by enhanced melting and runoff from the ice surface. As Arctic warming continues, the intensity and extent of Greenland's surface melting are projected to increase, leading to greater ice mass loss and increased liquid water atop, within, and beneath the ice sheet. Understanding the passage of meltwater from its origin to the ocean is crucial for assessing Greenland's future contribution to sea level rise and its impact on the wider Arctic system. Meltwater generated at the ice sheet surface penetrates to the bed via moulins and crevasses, and the subglacial hydrological system rapidly responds to water input. The temporal variability in subglacial water flow exerts a key control on the overlying ice dynamics. A recently discovered component of Greenland's subglacial hydrological system is its network of active subglacial lakes. These lakes are primarily fed by surface meltwater penetrating to the ice sheet base, and have the potential to force large volumes of water through the subglacial system when they drain, altering its morphology and the dynamics of the surrounding ice. This study presents observations of a destructive mode of Greenland's subglacial lake drainage and analyzes its impact on the surrounding ice sheet. The researchers used very high-resolution Arctic DEM digital surface models and satellite imagery to identify and monitor a previously undetected subglacial lake in northern Greenland. During a 10-day period in the summer of 2014, a 2-kilometer square region of the ice surface dropped by 85-meter elevation, forming a deep collapse basin in the ice surface. The rapid deflation, which occurred approximately 25 kilometers inland on slow-flowing ice adjacent to the main glacier, followed shortly after the seasonal runoff maximum. Before this event, the basin surface had been rising, forming a 10 to 15-meter high dome above the surrounding ice. Following the 2014 surface collapse, uplift of the ice within the basin resumed before it subsided by approximately 10 meters between 2017 and 2019. The researchers interpret this dynamic behavior to be the surface expression of an active subglacial lake similar to those observed previously in Greenland and Antarctica. The estimated discharge rate represented an approximately 30-fold increase in the daily meltwater runoff flux generated across the entire Harder Glacier catchment at that time, suggesting that lake drainage exerted a substantial perturbation on the downstream subglacial system. The study found evidence of a contrasting mode of ice sheet drainage pathway. Approximately 1 kilometer downstream of the collapse basin, a newly formed zone of fractures appeared in the ice surface, consisting of crevasing and uprooted ice blocks with a combined height of 40 meters. Downslope of the fracture zone, an approximately 6-kilometer square region of the ice surface, had been scoured clean. These observations indicate that a substantial volume of water broke up through the ice at this location and flooded across the surface. The hydraulic potential difference between the lake and the fracture site indicates that the floodwater had sufficient hydraulic head to reach the surface at the fracture location. The study highlights the need to fully understand the underlying theory of subglacial water flow and fracture mechanics in such systems, and to better constrain the distribution and dynamics of water beneath Greenland in its entirety. The findings challenge the classical model that meltwater flow is always unidirectional from the ice sheet surface to its base, instead demonstrating that water can travel from the surface to the bed and back again over short spatial and temporal scales. Retention hooks. The Greenland ice sheet is losing mass at an alarming rate, contributing significantly to global sea level rise. The study presents observations of a destructive mode of Greenland's subglacial lake drainage and analyzes its impact on the surrounding ice sheet. The findings challenge the classical model that meltwater flow is always unidirectional from the ice sheet surface to its base. Controversy. Comment hooks. And here's where it gets controversial. The study suggests that the subglacial lake drainage may have been triggered by a previously unknown mechanism, challenging our current understanding of the Greenland ice sheet's hydrological system. And this is the part most people miss. The study's findings have significant implications for our understanding of the Greenland ice sheet's contribution to sea level rise and the impact of climate change on the Arctic system. Tone of voice, friendly. The study's findings are presented in an approachable and easy-to-understand manner, making the topic of subglacial lake drainage accessible to a wide audience. Conversational. The text is written in a conversational tone, with the use of transitional phrases and sentences that connect the ideas and make the content flow smoothly. Informative. The study provides a wealth of information on the topic of subglacial lake drainage, including its impact on the surrounding ice sheet and the wider Arctic system. Professional. The language used is technical and precise, reflecting the academic nature of the study and the expertise of the researchers. 90 billion liters of water punched through Greenland's ice sheet, and nobody noticed. Imagine a colossal burst of water breaking through solid ice, an event so massive that it reshapes our understanding of the Greenland ice sheet, yet it went unnoticed for years. This astonishing occurrence happened in 2014 when an immense accumulation of meltwater beneath Greenland's ice sheet surged upwards, fracturing tens of meters of solid ice and releasing water into the open air. This is not just a curious natural event. It marks the first time scientists have witnessed such a powerful eruption in Greenland, revealing critical insights about how this enormous ice mass may change as it continues to thaw amid climate change. But here's where it gets controversial. This discovery forces us to rethink the hidden forces at work beneath the ice and challenges assumptions about the stability of these seemingly impenetrable ice sheets. The meltwater beneath isn't just quietly flowing. It can build up pressure intense enough to literally punch holes in kilometers-thick ice, unleashing floods that reshape the landscape. Glaciologist Jade Bowling from Lancaster University in the UK highlights how subglacial lakes under Greenland's ice remain a relatively recent discovery, and our understanding is still developing. Our research shows that we know very little about how these lakes change over time and, crucially, how their draining impacts the surrounding ice, Bowling explains. Questioning the frequency and consequences of these drainage events is vital because it could suggest just how vulnerable Greenland's ice sheet is to sudden changes. Greenland's ice sheet itself is a vast frozen expanse covering most of the island with ice more than 3 kilometers, 1.9 miles thick in places. This enormous volume of ice traps staggering amount of water, so much that if it were to melt entirely, global sea levels would rise by approximately 7.4 meters, about 24 feet. Recent advances in radar-equipped aircraft have allowed scientists to peer beneath the ice surface, revealing a complex, dynamic under-ice landscape where liquid lakes emerge and recede, sometimes causing the overlying ice to bulge upward in phenomena aptly named water blisters. What Bowling and her colleagues uncovered using satellite data was unprecedented. Over a brief 10-day stretch in late July to early August 2014, an area spanning 2 square kilometers suddenly dropped in height by an astounding 85 meters, about the height of a mid-sized skyscraper. Before this dramatic collapse, however, the same area had been rising steadily by 10 to 15 meters as water pressure created an icy dome. The sudden drainage released roughly 90 million cubic meters of water, equivalent to about 90 billion liters, unleashing an enormous subglacial flood. Further downstream, about a kilometer away, the researchers found the aftermath, a heavily fractured ice field scattered with massive ice blocks towering up to 25 meters. Beyond this, a 6 square kilometer zone of the ice sheet was scoured clean, essentially wiped bare by the rushing water. At first, we doubted our data because the event was so unexpected, Bowling admits, but deeper analysis confirmed we witnessed the fallout of a massive flood breaking free from under the ice. This fracture zone is where the water finally burst through, gouging out paths as it spilled onto the surface. While scientists have long known that meltwater travels beneath the ice, this is the first documented case of meltwater violently punching right through the ice sheet itself. As Greenland's ice continues to melt rapidly, this finding adds an important piece to the puzzle of understanding ice sheet stability and behavior. Amber Leeson, a fellow glaciologist at Lancaster, emphasizes how surprising the study's results were and why they matter. This event revealed unexpected ways ice sheets respond to intense surface meltwater input, Leeson says. It underscores the urgency to deepen our knowledge of the ice sheet's complex internal water systems now and for the future. Because subglacial water systems play a pivotal role in controlling ice sheet motion and melting rates, improving our grasp of these hidden processes is crucial for predicting sea level rise. Satellite observations like these will be instrumental in future research. This groundbreaking study has been published in the journal Nature Geoscience, opening new avenues for debate and investigation. So here's the question to you. Does this discovery change your perspective on how fragile or resilient ice sheets really are? Could such sudden flooding events become more common with climate change, accelerating ice loss faster than expected? We'd love to hear your thoughts. Do you find this alarming, hopeful, or a call to action? Share your views and join the conversation below.